Hello, hello. Welcome back, everybody. We're continuing on week 2, number 11, contains duplicates. This one's going to be LeetCode 217. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. Here's an example. Nums 1, 2, 3, 1, true. 1 appears twice. 1, 2, 3, 4, false. 1, 1, true. I mean, you already know it's true by the first two. Okay, so let's think about how to do this. There's probably many ways to solve this. No clear single way. Contains duplicate. You imagine we have an example. Let's just take example 1, 1, 2, 3, 1. Now, in a pinch, if you have to brute force this, one thing you can do is for every single element, you run a for loop on the remaining to see if it matches, right? And this is going to be n squared because for this one, you have to do the rest of it. For this one, you have to do the rest of it. And it's n squared because you're doing a nested for loop, right? So this is not what you're probably doing in your brain when you look at the problem. What you're probably doing in your brain when you look at the problem is you're probably scanning, right? You're probably scanning throughout, and this array is small enough where as you scan, you're going to keep some stuff in memory. Like, oh, I saw this twice. Oh, I saw this twice, right? So you probably have some type of memory bank. And when you see the 1, maybe you put the 1 in there. When you see the 2, maybe you put the 2 in there. When you see the 3, maybe you put the 3 in there. And when you see the 1 again, you say, oh, you know what? I've seen this already. This is actually right here. So this is also a way to think about solving this. As we're iterating through the array, what if we keep some type of set? And once we have an overlap with the set, we know that we found a duplicate. That's definitely a way to solve this. And what is the cost of this? Well, runtime is going to be O of n, right? It won't be n squared anymore, but we're going to keep a memory, right, of O of n. This could be potentially as long as the list. Imagine if this went from 1, 2, 3 all the way to 1,000,000 with no duplicates. We're going to keep a set with all 1,000,000 items in there, right? So O of n. Whereas before, when we did the nested for loops, it didn't take any extra memory. It was just a for loop and a for loop. We weren't creating a set. We weren't saving many other things. You could think of another way to solve this. It's not any more helpful, but you could think about creating a counter object. So if you already had functionality to create a counter, at your workplace, a teammate already has some code that has a counter object, or maybe a create counter, and then you pass in the list, and then there's a counter. You'll have something like 1, and maybe that appears 8 times, 2, maybe that appears 7 times, 3, maybe that appears once, and then all you have to do is check to see if any of these appear more than once, right? And here at the 8, here at the 7, it does. For us, for our purposes, it doesn't actually do much better than the set. And the set has one unique attribute. It allows you to exit early, right? So if the list had 1, 1, 1, 1, 1, really on the first 2 ones, we know there's already a duplicate, right? We don't have to count the rest of the ones. So I'm going to go ahead and delete this counter. I'm going to go ahead and delete this. I think for now, this setup that we have is pretty good, right? So what is the variable here? Variable here is nums. You'd imagine if we wanted to write the code, we need to iterate for n in nums, right? If n in whatever set that we have, then return true. There's a duplicate. right? Otherwise, what we're going to do is add n to the set. So add n to set. And this is the code. We initialize a set somewhere in the function, create set, and that's what we need to do. All right, let's do this. So I'm going to go ahead and copy this code here where we create set. It's not actually how you create set, so I believe it's something like we'll call it number seen, and that is set. So if you don't have a set in your language, I'm pretty sure most languages support it now, even JavaScript, you can use a hash map, and that could be, every key is the key, and every value could just be true or 1 or any value that you feel like could be there. So for n in nums, if the n is in this set number seen, that means we've already seen this number, seeing it for the second time. Let's just go ahead and return true, right? This list of integers contains a duplicate. And then otherwise, let's just add n to the set. I believe sets have an add method. Go ahead and add there. And by default, let's go ahead and return false. If we never have a clash, let's return false. All right, so I accepted our cases 1, 2, and 3. And, I want you to think about how we solved this problem. We did what we kind of examined what we looked at in our own reading of this problem. Maybe sometimes if these numbers were really big, you would require a nested for loop, right? Otherwise, you're basically scanning, you have this memory. Let me give you an example, actually. This is kind of a tangent. Let's imagine that this is the problem. And you're scanning, right? It's possible that even in your own mind, it's hard to do a single scan. You might need to do a nested for loop, right? Because some of these numbers look so similar. But with a computer, there's no confusion about the numbers. You put in the set, and if you're going to look for set inclusion, basically that in, then it's going to be perfect memory here. So here it looks like memory, we beat 65%. So maybe some people are doing this without the memory, right? Like maybe they're doing the nested for loop, and that could be, interesting as well, right? So what that would look like, I'll leave that as an exercise for the reader. But what it would look like is you create a for loop, right? Iterate from n to nums, and then you want to create a second loop that starts on the inner, right? That starts here. That always starts here. So here's the first loop. This is the start. This red one goes all the way to the end, and then, right, you iterate all the way down, except you exclude. You don't really need to iterate on the last element when there's only one element. Well, I'll leave the nested one up to the reader, but thank you for this quick one, and looking forward to the next one.